The biggest megaprojects in the United States represent the pinnacle of modern engineering. Pushing the boundaries of what is technically possible, these colossal projects are redefining the nation's infrastructure and technological capabilities. Today, we will delve into the most monumental megaprojects in the States and reveal the staggering complexity involved in bringing these behemoths to life. Let's travel to Los Angeles for the LAX International Airport Modernization Project. The initiative is slated for completion in 2028 prior to the Olympic Games and is currently one of the most significant infrastructure undertakings in the United States, with a budget exceeding $14 billion. Spanning over 1,700 acres, the airport project aims to accommodate increasing passenger numbers, projected to rise to over 100 million annually by the end of the decade. This extensive modernization includes the construction of new facilities, enhancement of existing structures, and the introduction of innovative transport systems. The project involves the addition of more than 3 million square feet of terminal space, effectively increasing the airport's size by 25%. This addition is equivalent to about 42 football fields laid side by side. The centerpiece of the project, the midfield satellite concourse, alone spans 750,000 square feet, featuring 12 new aircraft gates. Additionally, the project features a centralized utility plant upgrade that employs 6,000 solar panels and an advanced water reclamation system, which together aim to cut energy consumption by up to 25%. Challenges faced during this vast project include maintaining airport operations during construction. Solutions have involved intricate phasing of construction activities and the use of real-time analytics to manage flow and logistics across the sprawling site. It's time to travel to the state of Texas, where Tesla's Gigafactory is located. This sprawling facility, initiated in July 2020, underscores Tesla's commitment to scaling up its production capabilities, particularly for the Tesla Cybertruck and Tesla Semi. Occupying over 2,500 acres along the Colorado River, Giga Texas is designed to be an eco-friendly facility, integrating closely with the surrounding environment. The site is one of the largest buildings in the world by footprint, featuring approximately 10 million square feet of operational space spread over several floors. This size equates to about 172 football fields, providing a visual of the vast scale of this project. The total investment by Tesla into this project is expected to exceed $1 billion, which is anticipated to inject significant economic activity into the local and state economy through direct employment and ancillary benefits to suppliers and service providers. Giga Texas is pivotal in solving the logistical challenges associated with Tesla's supply chain, aimed at reducing shipping costs and production bottlenecks. It is set to become a critical hub for Tesla's operations in the eastern United States, enhancing the company's distribution logistics across the East Coast and international markets. The factory's location was strategically chosen for its proximity to rail and road networks, facilitating efficient material shipments and distribution of finished vehicles. We move over to New York next for the Hudson Tunnel project. This massive project aims to construct a new rail tunnel under the Hudson River, directly addressing the critical need for modernized and reliable rail connections between New Jersey and Manhattan. Currently estimated to cost around $11.6 billion, the Hudson Tunnel project involves constructing a new two-track rail tunnel, refurbishing the existing century-old tunnel, and making related infrastructure improvements. Upon completion in 2026, it is expected to significantly reduce the risk of severe disruptions in daily commutes and national rail transport. The new tunnel's construction is a complex challenge, requiring sophisticated tunnel boring and under-river drilling techniques to navigate the geological and environmental sensitivities of the Hudson River's underwater terrain. The existing North River Tunnel, which currently serves as the only rail link under the Hudson for Amtrak and New Jersey Transit trains, has been in service since 1910 and was severely damaged during Hurricane Sandy in 2012. The construction of the new tunnel will allow this old tunnel to be closed for repairs without disrupting the critical train services it provides. To understand the scale of the Hudson Tunnel project, consider that the new tunnel will extend about 2.5 miles under the riverbed, involving millions of cubic feet of excavated earth, enough to fill over 1,000 Olympic-sized swimming pools. The project's challenges are immense, from navigating bureaucratic hurdles and securing funding agreements across multiple government entities, to the physical difficulties of urban tunneling. But what about the redevelopment of an entire train station? That's what happened with New York's Moynihan Train Hall. This grand project, completed in January 2021, seamlessly blends state-of-the-art facilities with historic architectural elements. The project cost approximately $1.6 billion, a strategic investment aimed at reviving the Midtown area and providing New York commuters and travelers with a more dignified and spacious environment. Construction of the train hall was a logistical challenge, requiring the coordination of thousands of workers in a densely populated urban area. The workforce fluctuated throughout the project, peaking at around 1,200 workers during its most intense phases. These individuals were involved in intricate tasks ranging from restoring the century-old steel trusses to integrating modern technology and security systems within the structure. The Moynihan Train Hall solves several pressing problems associated with the original Penn Station: overcrowding, lack of natural light, and limited amenities. By expanding into the Farley Building, the project has effectively increased the station's total footprint, allowing it to serve up to 700,000 passengers daily. The hall's design features a dramatic 92-feet-high skylight that arches over the main concourse. This skylight, covering an area of 31,000 square feet, not only illuminates the space with natural light, but also serves as a modern counterpoint to the Farley Building's Beaux Arts facade. It's time to travel to San Francisco next, where the gigantic Chase Center is one of the city's biggest megaprojects. Located in the Mission Bay neighborhood of the city, Chase Center serves as a state-of-the-art arena primarily for the Golden State Warriors, and a versatile venue for concerts and other events. This mega project, completed in September 2019, was a private sector initiative spearheaded by the Warriors' ownership, costing an estimated $1.4 billion. Chase Center covers an area of 11 acres and includes an 18,000-seat arena, 2 office buildings, 100,000 square feet of retail space, and a public plaza. The project also involved the creation of a waterfront park along with a half-mile of restored public waterfront. One of the challenges in its development was integrating the center with San Francisco's existing public transport networks. This led to significant improvements in local infrastructure, including the addition of a Muni Metro light rail platform and the enhancement of nearby roads. The use of cutting-edge seismic technology was a focal point, considering San Francisco's susceptibility to earthquakes. This included innovative base isolators and shock absorbers that ensure the arena can withstand significant seismic events. Chase Center's unique architectural design and construction methods included the use of sweeping glass facades and intricate metalwork that complements the bay's maritime setting. If you consider the height of the arena at nearly 135 feet, it stands tall enough to house the Statue of Liberty inside it, giving a sense of the scale at which this construction was conceptualized and executed. Moving over to Chicago, we have to talk about the Lincoln Yards megaproject. This expansive plan, spearheaded by Sterling Bay, is a $6 billion redevelopment plan that is reshaping over 55 acres of former industrial land into a vibrant, mixed-use complex. Upon its phased completion, with projections spanning the next decade, Lincoln Yards aims to serve as a new epicenter for residential living, commercial activity, and cultural flourish in Chicago. A pivotal element of Lincoln Yards is its promise to create upwards of 24,000 full-time jobs during its construction phases, involving a vast array of trades and specialties. At its core, Lincoln Yards is designed to address the pressing need for urban revitalization and connectivity between Chicago's northwestern neighborhoods, effectively bridging a gap that has long segmented the city. The development encompasses over 14 million square feet of buildings, including high-rise residential towers, office buildings, and an array of retail spaces. One of the major challenges Lincoln Yards faces is integrating this vast new development seamlessly with existing infrastructure. The plan includes substantial improvements to local transit systems, including a new metro train station, multiple new bridges over the Chicago River, and enhanced pedestrian and bike paths to ensure accessibility and reduce traffic congestion. An ambitious aspect of the Lincoln Yards project is the proposed Live Nation Entertainment District, which will include multiple venues for concerts and cultural events, capable of hosting thousands of visitors. This entertainment component is envisioned to be comparable in scale to London's O2 Arena district, albeit integrated within a larger mixed-use development. But what about one of the tallest skyscrapers in New York City? Located in the bustling Hudson Yards district of Manhattan, the Spiral Tower stands as a pinnacle of architectural innovation and modern design. Officially known as 66 Hudson Boulevard, this towering skyscraper reached its completion in 2022, emerging as one of the most distinctive profiles against the NYC skyline due to its spiraling green terraces that ascend with the building's rise. The spiral spans 65 stories, measuring approximately 1,041 feet in height. The project carried a substantial financial commitment, with development costs estimated at around $3.7 billion. The construction of the spiral employed approximately 7,600 workers across various phases, reflecting its scale and the complexity of its design. This architectural marvel was conceived to offer a blend of premium office spaces and expansive green outdoor terraces on each floor, integrating nature into the urban workspace. Each terrace is equipped with foliage and seating areas, providing accessible outdoor space to office occupants, a rare feature in Manhattan's dense urban landscape. The construction of the spiral involved innovative building techniques, particularly in the integration of its steel superstructure with the cascading terraces. Advanced computer modeling and precision fabrication were crucial to ensuring that each floor's outdoor space seamlessly aligns with the spiraling design. The spiral's total floor area is about 2.8 million square feet, roughly equivalent to the size of 50 football fields. However, the project wasn't without challenges. Its construction phase coincided with the pandemic, which posed significant logistical challenges, delaying materials and reducing workforce efficiency due to health and safety protocols. Yet, the project team adapted with enhanced safety measures and scheduling adjustments to mitigate these impacts. Next up, we have to talk about the Atlanta Beltline project. Envisioned as a comprehensive revitalization effort, the Beltline aims to convert a historic 22-mile railroad corridor encircling downtown Atlanta into a multi-use trail, modern streetcar line, and expansive green space. This grand project, which began in the early 2000s and is expected to continue in phases through 2030, is not only redefining urban transit, but also enhancing community connectivity. With an estimated cost exceeding $4.8 billion, the Atlanta Beltline is one of the largest, most wide-ranging urban redevelopment projects in the United States. It involves the coordination of multiple city departments and private contractors, engaging thousands of workers over its multiple phases of development. The Beltline addresses several critical urban challenges, including the need for improved public transportation options. By connecting 45 in-town neighborhoods with multi-use trails and transit options, it promotes a more sustainable lifestyle, reducing reliance on automobiles and encouraging walking, biking, and public transit. A notable feature of the Atlanta Beltline is its use of existing railroad tracks for the trail and transit system. The project has faced challenges, particularly in terms of funding and community engagement. Balancing the diverse needs and expectations of various stakeholders, residents, and city officials has required continuous dialogue and adaptation. Additionally, the Beltline has navigated complex logistical challenges associated with constructing and maintaining infrastructure across active urban environments without significant disruptions to the daily lives of Atlanta's residents. It's time to move over to Boston now for the Green Line Extension Megaproject. This extension aims to enhance public transit services by connecting the densely populated but underserved areas of Somerville and Medford to the existing subway network, thereby increasing accessibility to central Boston. Launched with major construction efforts ramping up around 2018, the GLX project completed in 2023. The project's budget, initially estimated at $2 billion, saw an increase to nearly $2.3 billion due to unforeseen construction and environmental challenges. Spanning approximately 4.7 miles, the GLX adds 7 new stations along 2 branches, one terminating at Union Square in Somerville and the other at Tufts University in Medford. These new tracks and stations are expected to serve about 45,000 riders daily, significantly easing traffic congestion and reducing commute times in these high-density corridors. The workforce required for this mammoth project varied throughout its phases, involving up to 1,000 construction workers and engineers at peak times. One of the most critical problems the GLX project addresses is the reduction of vehicle emissions by providing a reliable and efficient public transit alternative, thereby contributing to the state's environmental goals. In terms of construction, the GLX employed advanced methods including the use of track-laying machines that allowed for faster, more efficient installation of rail lines. This project also involved substantial upgrades to existing infrastructure, such as the improvement of bridges and roads along the extension path, ensuring that the new service would be integrated smoothly with minimal disruption. Challenges encountered during the GLX project included managing complex logistics in densely populated areas, mitigating noise and disruption to local communities, and addressing cost overruns and delays, which were exacerbated by the pandemic. Next up, it's time to travel to New York for the Bayon Bridge raising project. This development is an extraordinary engineering feat located over the Kill-Van-Kull Strait, connecting Staten Island, New York, to Bayon, New Jersey. This project was initiated to address the critical need for modern cargo ships to access the ports of Newark and Elizabeth, New Jersey, which are among the busiest on the eastern seaboard. The original bridge, completed in 1931, had a navigational clearance that was too low for the new generation of ultra-large container vessels introduced with the expansion of the Panama Canal. Completed in 2019, the project successfully raised the bridge's roadway from 151 feet to 215 feet above the water level, while also maintaining the iconic arch design. This adjustment made it possible for ships nearly twice the size of those previously accommodated to pass underneath, significantly increasing the operational capacity and efficiency of the port facilities. The project cost was approximately $1.7 billion, reflecting both its scale and complexity. One of the significant challenges was executing the work without disrupting the heavy vehicular traffic on the bridge, which necessitated innovative construction methods and careful scheduling. In terms of its engineering methodology, the project was notable for its use of the raise the roadway technique. This method involved building a new roadway above the existing one while traffic continued below, and then removing the lower roadway upon completion. Comparing the scale of the Bayon Bridge project to other engineering projects, its new 215 feet clearance is high enough to accommodate an NFL football field standing on end. The Bayon Bridge raising faced numerous challenges during its execution, including technical difficulties inherent in working with existing structures, the need to maintain stringent safety standards, and the unpredictable weather conditions over the strait. The project also had to navigate complex regulatory and environmental approvals, coordinating with multiple governmental bodies and community stakeholders to mitigate impacts on the surrounding areas. Let's travel over to North Carolina, where the Charlotte Gateway Station is being constructed. This significant development, a central hub designed to integrate various modes of transportation including Amtrak, buses, and future light rail services, is part of a larger vision to improve transit connectivity across the region. Scheduled for full operational status by 2025, the Charlotte Gateway Station began its early phases in 2018 with a budget projected to exceed $800 million by the project's conclusion. The station itself will cover several city blocks, featuring a state-of-the-art passenger terminal, bus bays, and extensive parking facilities. The project's total area is comparable to 20 football fields, emphasizing its scale and the transformational impact on the city landscape. It is expected to serve thousands of passengers daily, significantly easing the city's traffic congestion and providing a more efficient, reliable public transportation network. One of the primary challenges has been coordinating the multiple phases of construction while minimizing disruptions to the existing traffic and businesses in downtown Charlotte. The station's design features include expansive glass facades to maximize natural lighting and open public spaces that encourage pedestrian traffic, reflecting new trends in urban station aesthetics and functionality. In comparison to other transportation projects like the Moynihan Train Hall in New York City, the Charlotte Gateway Station is unique in its incorporation of green building practices and its role in catalyzing economic development in a mid-sized American city. Despite challenges such as budget adjustments and the complex logistics of constructing in a dense urban core, the Charlotte Gateway Station is set to become a critical node in North Carolina's transportation network. But what about a massive dam megaproject? For that, we have to travel to the Ohio River, where the Alstad Locks and Dam project is located. This monumental undertaking, designed to replace aging infrastructure and modernize the waterway system, is crucial for the transportation of billions of dollars worth of goods annually across central U.S. This project, which officially completed in 2018 after over 30 years of planning and construction, spans across the river and involved an extraordinary financial investment of approximately $3 billion. The construction required the sustained effort of hundreds of engineers, technicians, and laborers over several decades, underscoring the project's scale and complexity. The Alstad project replaced two older and less efficient facilities, Locks and Dams 52 and 53, which had become increasingly unreliable, causing significant delays in river traffic and logistical inefficiencies. The new structure consists of a navigational pass and two parallel 110 feet by 1,200 feet locks. This setup significantly eases the river traffic, allowing for the smooth passage of approximately 90 million tons of cargo yearly. One of the notable challenges of the Alstad Locks and Dam was its innovative construction method, specifically the use of in-the-wet technology. Unlike traditional dry dock methods, this technique involves assembling large modular sections of the dam on land, then floating them to their installation site on the river. The total amount of concrete used in the dam's construction would be enough to pave a sidewalk stretching from New York to San Francisco. A special feature of the Alstad Locks and Dam is its resilience to seismic activity. The region is near the New Madrid fault line, and as such, the structure was designed to withstand significant earthquakes, ensuring the long-term stability and safety of this critical infrastructure. The project's importance extends beyond just its immediate functionality. By improving the reliability and efficiency of the Ohio River as a navigational channel, the Alstad Locks and Dam also bolsters the economic viability of river transportation, which is significantly more fuel efficient and environmentally friendly compared to road and rail transport. But how about an entire stadium being replaced? The Aloha Stadium Replacement Project, located in Aloha, Hawaii, is a significant undertaking aimed at revitalizing the sports and entertainment capabilities of Hawaii's most populous island, Oahu. This ambitious project replaces the aging Aloha Stadium, originally built in 1975, which had become increasingly costly to maintain and no longer met modern safety or functionality standards. Scheduled for completion in 2028, the new stadium complex is anticipated to cost over $350 million. The project covers an extensive area of approximately 98 acres, with the new stadium expected to seat around 35,000 spectators, down from the old stadium's capacity but designed to offer improved sightlines and amenities. This size makes it comparable to the StubHub Center in California, though with enhanced technological integrations. Employing around 2,000 workers during peak construction phases, the project faces the unique challenges of building in an island setting, such as logistics complications related to material shipping and the high cost of labor and supplies in Hawaii. The new stadium will employ modern construction techniques, including the use of sustainable materials and energy-efficient designs to minimize its environmental footprint. Features like solar power generation and water reclamation systems are planned to make it one of the greenest stadiums in the nation. A key problem that the new Aloha Stadium aims to solve is the economic inefficiency of its predecessor. The old stadium was underutilized, partially due to its deteriorating condition and lack of modern facilities that limited event hosting capabilities. The new complex, with its state-of-the-art features, seeks to attract more high-profile events and, consequently, generate significant economic benefits for the region. One innovative aspect of the project is its integrated approach to development. The stadium complex will include mixed-use developments such as hotels, retail spaces, and residential areas, creating a vibrant community hub rather than just a sports venue. This model follows the trend seen in projects like the Atlanta Braves' Truist Park, which integrates a stadium with a larger commercial and residential district. We have to talk about the 2nd Avenue Subway Megaproject next, located in New York City. Officially part of the Metropolitan Transportation Authority network, this new subway line runs along 2nd Avenue on the east side of Manhattan. The project has been in the conceptual and developmental stages since 1920, but saw its first phase completed and opened to the public on January 1, 2017. Phase 1 of the 2nd Avenue subway cost approximately $4.45 billion and included 3 new stations with a new terminal at 96th Street. The construction of the 2nd Avenue subway involved approximately 6,000 workers at various stages, tackling complex urban engineering challenges such as tunneling beneath densely populated areas and avoiding disruptions to the existing utility infrastructures. This necessitated the use of tunnel boring machines, which are sophisticated pieces of equipment that can efficiently cut through New York's bedrock while minimizing vibrations that could damage building foundations above. The 2nd Avenue subway covers a planned total length of 8.5 miles, once all phases are complete. To put the scale of this project into perspective, the total length of the new subway line would be equivalent to more than 146 football fields laid end to end. Each station is built with expansive, column-free platforms and high ceilings to enhance passenger comfort and safety, a notable departure from many of the city's older subway stations. The 2nd Avenue subway has faced numerous challenges, including budget overruns and delays primarily due to the complexities of constructing a new subway line in one of the world's most built-up urban environments. Comparatively, the cost and scope of the 2nd Avenue subway are similar to those of the Crossrail project in London, although the latter is even larger in scale. Up next, it's time to investigate the Goethals Bridge. This project is a significant architectural feat in the United States, linking Elizabeth, New Jersey to Staten Island, New York. The bridge was originally constructed in 1928 and underwent a massive rebuilding project that began in 2014 and concluded with the opening of its eastbound span in 2018. The total project cost was approximately $1.5 billion, highlighting its scope and the investment required to modernize critical infrastructure. Designed to replace an aging structure that could no longer efficiently handle modern traffic volumes, the new Goethals Bridge features twin spans, each supporting 3 lanes of traffic, additional shoulders, and a pedestrian and bike pathway that will be completed in a future project phase. One of the most notable methods used was the modular construction approach. Large segments of the bridge were prefabricated off-site and then transported to the location for assembly. This method not only sped up the construction process, but also minimized environmental impact and disruption to the existing traffic. The Goethals Bridge project was a technical challenge, involving the installation of 60 feet tall piers and the lifting of massive 900-ton segments into place. The bridge spans a total length of 1.4 miles, with each of the twin spans stretching approximately 900 feet in their longest span section, requiring precision engineering and construction expertise. One unique aspect of the Goethals Bridge is its focus on sustainability. The project included measures to protect the local marine environment and featured the extensive use of recycled materials. Moreover, the bridge's design incorporates energy-efficient LED lighting and has provisions for future smart transportation technologies.